We're absolutely swimming in information these days. Finding it isn't the problem, right?
Right.
The real trick is figuring out what actually matters, what to focus on, how to boil it down into something useful.
Exactly.
That's what we're here for. Think of this deep dive as your shortcut to really getting a handle on a critical concept. Today, that concept is role-based access control in Kubernetes. RBAC.
Ah, yes. RBAC.
If you work with Kubernetes at all, you've definitely heard of it.
Uh-huh.
But, what is it really? Why is it so completely essential? And how does it actually work under the hood?
Yeah, lots of questions there.
We're going to unpack all of that today.
Absolutely. And we've looked at quite a bit of material on RBAC. It lays out the fundamentals pretty clearly.
Perfect.
So our mission today is simple. Give you a sharp, concise, and really actionable understanding. We're pulling out the key nuggets for you.
Okay, let's do it. Let's unpack RBAC. So, at its heart, what are we talking about?
Well, it's a security mechanism, fundamentally.
Right. Security.
Its job is to control who can do what. And the who could be, actual users or maybe groups of users or even automated services.
Okay. And the what is actions on resources.
Precisely. Actions on things inside your Kubernetes cluster. Its whole purpose is defining permissions through these things called roles and bindings.
Roles and bindings. We'll get into those.
Yeah, and they make sure only the authorized folks or services can touch or change Kubernetes objects. Your pods, services, namespaces, all that stuff.
Got it. So it's the gatekeeper.
In essence, yes. And what's interesting are the key ways it defines those permissions. You've got roles, and then you've got cluster roles.
Okay, difference.
Big difference. A role gives permissions, but only within a specific namespace, so it's very contained.
Like the dev namespace or the prod namespace.
Exactly. Whereas a cluster role, well, that's cluster-wide. Permissions that apply across all namespaces, or maybe to cluster-level things like nodes themselves.
Okay. That namespace versus cluster-wide distinction seems pretty fundamental.
It is. Hugely important for how you structure access.
So does that mean in like a big company with lots of teams, you just slap cluster roles everywhere for simplicity? Or is that risky?
That's a fantastic question. It really hits on the principle of least privilege.
Right. Only give what's needed.
Exactly. Now, cluster roles are necessary for certain things, managing nodes, CRDs, that kind of cluster admin task.
Yeah.
But using them too broadly, or giving really powerful cluster roles to regular users or standard service accounts, that can, well, open you up to significant risk pretty quickly.
I can see that. Easy mistake to make early on.
Very common pitfall. Maybe a team grants a wide cluster role for some automation, thinking it's easier, but they don't realize they've just created a massive potential security hole. Precision is key, always.
Okay, precision. That makes sense. And then you mentioned bindings. What role do they play?
They're the glue, the critical link. You have role bindings and cluster role bindings. Yeah. These are what actually connect those roles or cluster roles you defined to the actual users or groups or service accounts. They're what grant the permissions.
So the role says what you can do. The binding says who can do it.
You got it. And this system allows for incredibly granular control, like really fine-grained. You could say, okay, this person can manage pods, but absolutely not services, and only in this specific namespace.
Wow, okay. That's specific.
And that security focus is just paramount. It protects against unauthorized access, sure, but also misconfiguration, which, let's be honest, can cause some serious operational nightmares.
Definitely want to avoid those.
Yeah. So maybe analogy helps here for folks newer to this.
Yeah, let's hear it.
Think of RBAC, like a security guard standing at the entrance of a big office building that's your Kubernetes cluster.
Okay, got the guard.
The guard has a list, a rule book. Those are your roles. This list tells the guard what different visitors your users or services are allowed to do inside. Maybe they can go into certain rooms. Those are your resources. Now, the bindings are like giving specific visitors an ID badge, and that badge matches the rules on the guard's list.
The badge connects the person to the rules.
Exactly. It ensures only the right people. The ones with the right badge for the right rule can get into certain rooms or, change things inside the building, keeps everything secure and organized.
That's a great analogy. Really clears it up. So, using that analogy, what happens if the guard, RDAC, isn't trained right or has the wrong rule book? What are the real-world consequences?
Well, that leads us straight into the why this is so critical.
Right. And you see RBAC used everywhere in practice. like giving a developer permissions just for their app's pods in one namespace.
Perfect example. They can manage their stuff, but can't touch anything cluster-wide. Or maybe a monitoring tool, its service account needs to read pod metrics, right?
Yeah, but not change things.
Exactly. RBAC lets you grant just that read-only access, no modification ability. Or think about a CI/CD pipeline.
Okay. Deploying code.
Right, you can restrict it so it can only deploy applications into one specific namespace. Keeps everything else isolated and safe. That's RBAC in action.
Those are really concrete use cases.
Yeah.
So moving beyond the what in the examples,
Yeah.
why is RBAC not just, a good idea, but really essential?
Well, think about the context. Most Kubernetes clusters aren't simple single-user systems.
No, definitely not.
You've got multiple users, different teams, tons of automated systems all hitting the API server. It gets complex fast.
Chaos potential is high.
Exactly. Without a structured way to manage permissions in that kind of environment, potential chaos.
Yeah.
RBAC provides that essential structure. It's vital for security, absolutely, but also for compliance and just, frankly, keeping operations running smoothly.
Okay, so let's break down those key reasons. Why must you use RBAC?
The reason one, enhanced security. Plain and simple. It lets you lock down access to sensitive stuff like secrets and config maps.
Which often hold credentials or API keys.
Right. Things you absolutely don't want exposed. RBAC prevents unauthorized actions against those critical resources.
Got it.
This ties directly into the least privilege principle. It's a security best practice.
Mm-hmm.
RBAC is how you implement least privilege in Kubernetes. You grant only the exact permissions needed for a task, nothing more. That drastically cuts down your risk surface.
Makes sense. What else?
Team collaboration.
Mm-hmm.
Super important. If you have multiple teams sharing a cluster, RBAC lets them work safely side by side. You isolate their permissions, usually by namespace.
So Team A can't accidentally mess with Team B's stuff.
Precisely. Then there's compliance requirements. Think GDPR, IPA, things like that. RBAC helps you meet those standards because it gives you fine-grained control over who can access sensitive data or perform sensitive operations. You can actually prove who has access to what.
Auditability.
Huge part of it. And finally, automation support. Your applications, your CI/CD tools, they run as service accounts. RBAC lets these accounts do their specific jobs like deploying an app without giving them, God mode access to the whole cluster.
Right. Just what they need.
And something often missed here. It's not just about preventing bad actors. It's about operational resilience. By isolating permissions, RBAC massively reduces the blast radius if someone makes a mistake or a tool misbehaves.
Damage control.
Exactly. It can save you hours, maybe days of debugging and fixing things. It's security, yes, but it's also just smart operations.
Okay, those are compelling reasons to use it. So, flip side, right? What's the actual impact if you don't use RBAC or don't use it properly?
Well, the risks are pretty significant. Yeah. Without RBAC, you could effectively have users' services running with near admin level access.
Yikes.
Yeah. Unrestricted access. That just massively increases the risk of misconfigurations, accidental data deletion, data breaches, unauthorized changes, you name it.
That sounds like chaos.
It really can be. Imagine trying to manage permissions manually in a large cluster with multiple teams, or worse, just relying on default access levels. It's basically an open invitation for security vulnerabilities and, operational chaos. It just doesn't scale.
Any horror stories?
Oh, plenty. I remember one case, a team thought they were secure, but they had just one overly permissive cluster role binding. They gave it to a new CI/CD tool.
Oh.
And that tool accidentally had permissions to delete critical infrastructure components, and it did, in production.
Ouch.
Big ouch. Proper RBAC, a more scoped role binding, would have completely prevented that single point of failure.
Wow. That really drives home how critical this is.
Yeah.
Okay, so we know what it is, why it's essential. Let's get into the nuts and bolts of how. How does Kubernetes actually do this? When Alice tries to list pods, what's happening?
Right, the mechanics. So fundamentally, Kubernetes uses those pieces we talked about. Roles, bindings, and subjects. Subjects being your users, groups, or service accounts.
Okay.
Roles define the actions on resources. Bindings assign those roles to the subjects. And the key enforcer, the one checking everything, that's the Kubernetes API server.
The API server is the gatekeeper, checking the guards list and the visitors badge.
Exactly. More technically, it uses something called admission controllers. When a request comes into the API server before it actually gets processed, these controllers check it. RBAC functions as an authorization admission controller. It looks at the request, checks the user's roles and bindings, and says yes or no.
Oh, okay. Admission controllers, that's the enforcement point.
That's the key mechanism, yeah.
So could you walk us through the basic workflow, step by step?
Sure. Step 1, define a role or cluster role. You create a YAML definition for it. A role might specify permissions like get, list, create on pods or services, but remember, it's always tied to a specific namespace.
Okay. Define the rules first.
Right. Or you define a cluster role for those cluster-wide permissions. For example, a role might let you list pods only in the dev namespace. A cluster role might let you manage all namespaces cluster-wide.
Got it. Step 2.
Step 2, create a role binding or cluster role binding. This is another YAML object. The role binding links that role you just defined to a specific subject, say user Alice, within that same namespace.
Okay. Connecting the rule to the person in the right place.
Exactly. Or a cluster role binding links a cluster role to a subject, giving them those cluster-wide permissions. So our role binding might grant the pod reader role to Alice in the dev namespace. Now she can view pods there.
Makes sense. What's next?
Step 3, subjects make requests. Alice, our developer, uses kubectl, or some tool to interact with the Kubernetes API. Maybe she runs kubectl getpods-n dev.
Okay, she's asking for something.
Yes, and the API server instantly receives that request and sees it's from Alice for resources in dev. It immediately checks her permissions based on the role bindings or cluster role bindings that apply to her.
The check happens right then.
Instantly.
Yeah.
Which leads to step 4, permission enforcement. The API server, via that admission controller, looks at Alice's pod reader role derived from her binding. Does that role allow the get verb on the pod's resource in the dev namespace?
In this case, yes.
Yes. So the API server allows the action. Request proceeds. But what if Alice then tries kubectl delete my pod-n dev?
Ah, her role is just pod reader. No delete permission.
Exactly. The API server checks, sees her role, doesn't grant the delete permission for pods, and it denies the request. She'll get an error message, security enforced.
Clean.
Okay.
What's the final step?
Step 5 is dynamic management. RBAC isn't static. Your needs change. People join teams, leave teams, roles evolve. You can update these role and binding objects anytime using kubectl apply or similar tools.
So you can add or remove permissions on the fly.
Yep. Add a new role binding for a new developer, modify an existing role, remove a binding when someone leaves. Kubernetes picks up these changes automatically and enforces the new state immediately. It ensures your security posture stays consistent with your current needs.
That dynamic aspect is pretty powerful. Allows it to adapt.
Absolutely essential for real-world usage.
Okay, so let's quickly recap those key components just to make sure we've nailed them down. You've got the role.
Right. Permissions within a namespace.
The cluster role.
Permissions cluster-wide or across all namespaces.
Then the role binding or cluster role binding.
Linking those roles to your subjects, users, groups, service accounts, within a namespace or cluster-wide respectively.
And the big boss enforcing it all.
The API server, specifically using its authorization admission controllers, it's the central point of control.
It really is quite an elegant system when you break it down.
Right.
Simple concepts, but together they provide this really robust security foundation.
It is, and the key takeaway, especially if you're maybe newer to Kubernetes, think of RBAC as that smart security system for your cluster.
Right.
Roles are the rule books listing exactly what's allowed. Bindings are the keys given only to specific people or services. Put them together, and they keep your cluster safe and organized. They make sure only the right entities can access or change things. It simplifies security, really.
Nicely put. A clear, organized way to manage access. Okay, so that wraps up our deep dive into Kubernetes RBAC. We've covered the what's the core mechanism, the why it's absolutely critical for security, compliance, and just sane operations, and the how that elegant system of roles, cluster roles, bindings, and the API server, making it all work.
Yeah, and hopefully this has given you that shortcut we promised, a way to feel genuinely well-informed, confident about this really crucial piece of the Kubernetes puzzle. It might seem complex at first, but the core ideas are quite manageable.
Agreed. But, understanding it is one thing. Implementing and maintaining it effectively